Okay, so basically here we have the forecast that we did in the last video. Now what I want to do is I want to evaluate these and say, is k equals 2, k equals 3, or k equals 4 the best model? And we do this by calculating the error. And in fact, all I'm going to do is calculate the error metrics that are on page 334. Apart from we're going to use the mean squared error instead of square rooting it. So we're going to do the mean absolute error or mean absolute deviation, which is equation 9.2, well, actually 333. We're going to do the mean squared error, and we're going to do the mean absolute percentage error. We're not going to do the root mean squared error because it's whatever wins on the mean squared error for obvious reasons is also going to win on the root mean squared error, as one's just as the second is just the square root of the other. And I'm going to do it exactly as per the book example at the bottom of page 335. Then I'm actually going to tell you a little bit why I think you should make a slight alteration to that. So what we're going to do is we have these three forecasts, the k equals 2, the k equals 3, and the k equals 4. And what I'm going to do is I'm going to copy them to a new sheet. So select Control C. I don't know what's happening there. Select Control C. And then we're going to paste. And we're going to paste values. We're going to do it. We do values and source formatting, but we don't want to just do the paste. And that's simply because we're going to move these things around. And if they had formulas, then the formulas would go wrong. And what I'm going to do is I'm going to have basically leave 4 spaces between each of these forecasts. So I'm going to 1, 2, 3, 4, and this is going to be in, oops, we don't want to do that. We're going to put it here. This is going to be here. 1, 2, actually, it should be in M. Just delete. So we have our map. We have basically, these were our actual units sold, and these were our forecasts. So what we want to do is we want to actually calculate the error. And let's just, before we do any of this, let's just make sure that everything is Arial and 12. Okay, so we're going to create some error columns here, and I'll just actually copy this from the one I did previously, so I don't have to write them all out. And so we've got the error, the absolute deviation, the squared error, and the absolute percentage error. And obviously we can only calculate for forecasts, so we actually start here. So my error here is going to be, the definition is just going to be the absolute, minus the forecast, which gives us an error of -6. Now, the absolute deviation is just going to be the absolute value of that. So it's going to be the absolute value of B6 minus C6. Now, one thing I want to do is I want to put $1 on my B's because I'm going to kind of copy this across to the other values. And I want the B's to still be B's because even when we're looking at the moving average 3, we're still comparing with the actual in column B. So we have the absolute there. And now we have the square here. So B6 minus C6, but rather than absolute, we do to the power of 2. So that gives us a squared error of 36. And we also have a percentage absolute error. So that's going to be the actual, so it'll be B6 minus the forecast. Let's just put that in brackets. all over the actual. This is based on formula 9.5 on page 334 over 60. And that whole thing is going to be the absolute. So that's 0.1, but we actually want a percentage. If you look at the on the bottom of page 355, so we just multiply by 100. So that's 10% error. And we can actually just drop all the way down. Now we can't drop down to the last forecast because the last forecast is after the last period we have data for, so that wouldn't make any difference. So actually, here, these are the three metrics we're going to calculate. So we're going to calculate the mean absolute deviation, MAD, the mean squared error, and the mean absolute percentage error, MAPI. And what we're going to do is we're basically going to these are the absolute deviations, mean absolute deviation. Just the mean of all these values. Just check that's the same as the book. And squared error. Again, it's just the average. And then same again. Okay, one last little thing. I realized I need to put the dollar on the B. There's the denominator B's in the final column. So I'll just drop this down. Control D. Okay, so it doesn't change the value, but it means we can copy it across. So what I'm going to do now is basically everything. Control C. Now we can't do the top row because there's no forecast there, so that would come as an error. Control V. And as before, Control C, Control V. And let's just copy the titles across. Make these a little bit wider. And I'll talk about interpreting the results in a minute. Okay, so to match with the book on page 335, let's just put everything here, and then format cells, number to 2 decimal places. And then we pretty much have the same results. Now, I will say a proviso here. Oh, we need to put all these in light blue. Let's just pick the lightest of the blues, or the second lightest. And then light green. What was the second? We'll do that one. Looks quite nice. And then finally, bright red, light red. Let's just pick this one. A nice pink color here. Okay. Now, our original objective was to pick, these numbers are exactly the same as in the textbook. For example, you've got 13.63 for the absolute deviation, 14.86 and 16.13. Now, the idea of this example is we're trying to see which is the best fit. So at each stage we're making a forecast, we're making what's called a one-ahead forecast. So here, we're making a forecast using these values previously, but not this value. And then we're comparing and checking our error. So we're doing what we sometimes call one-ahead holdout validation. And we have these error metrics here. Now, ideally, these don't always agree, but we want the lowest of these metrics. So I would say here, 13.63 is the lowest absolute deviation. This is the lowest squared error. And this is the lowest absolute error. Now, where I have a little bit of an issue with the book is this is an average over weeks 3 to week 17. This is an average over, obviously it doesn't calculate anything there. This is an average over weeks 5 to week 17. So what I'm going to do is we're going to start off basically at kind of here. So this is going to be the average from E8 rather than E6. Control right, and I'm going to recopy that. I wanted to do the same as the book. Okay, so I'm going to be messing up my my colors, so let's just manually do 8, 8. And if we're going from 8, then we have, this is basically from week 5, we basically have week 5 estimates for all 3 of these, so we're kind of comparing oranges with oranges. Now we still see here that this k equals 2 gives the lowest error, gives both the lowest mean absolute deviation, mean squared error, and mean absolute error. But now I would say, because we're doing everything from week 5 to week 17, where both all k equals 2, k equals 3, and k equals 4 are making forecasts, then this is a much better kind of comparison. I wanted to give you the numbers in the book and then tell you a little bit how I would do it. So our conclusion here was that the k equals 2 is the lowest error, so we'd use k equals 2 for calculating our moving averages. Now we might want to use a wider variety number of k. We might want to use from 1 to 10. But from this little example, we did k2 to k4, and we found that k equals 2 was the best.